Yeah, we are discussing about functions, and in the last class, we have actually discussed about two terms, okay, related with function. The one is one-on function, and the under one is onto function. And I told you that these two terms, one-on function and onto function, can be defined with the help of the conditions, okay, which are used to define a function. But instead of one-on function, we need to write, instead of first set, we need to check the conditions on the second set. That is, so if there is no element without a connection in the second set, then we'll say that that is an onto function. Similarly, if there is no element with multiple connection in the second set, then we'll say that that is an one-on function. And last class I give you some examples where actually we can say that those are one-on functions or onto function. Now, if some function, okay, first of all, before going to that, so these two functions have some alternative name. So one-on function is also known as injective function. Okay, so this is known as injective function. Is it visible what I'm writing here?
Yes, sir.
Okay. And onto function has a name which is called a surjective function. Okay, which is called a surjective function. So you have to remember these two terms also. Injective means one, and surjective means onto. Now, if in case of some functions, if both happens, okay, if both injective and surjective happens, that means if we have a function which is both one and onto, or you can say if we have a function which is both injective and surjective, then the function is called bijective. Okay, so then the function is called bijective function. All right. Now, so last class, some of you have actually asked me one question: what is the importance of this? Okay, actually there are different lots of importance we have, but I'm not going to discuss about all of them. One importance is what? So with the help of this concept, okay, if we know that some function is bijective, then actually we can define the inverse function. Acha, before going to that, so we should know what is an inverse function. Okay, so when I was defining this function, I give an example. I told you that if we have a function which if we have a machine, and if we inserted sugar cane from this side, and if the sugar cane passes through this machine, we are getting sugar here. Now this was in function. Now if this happened, now consider that we have a machine like this. Okay, we have a machine this, where if we inserted those sugars again, okay, and from this side if we get the sugar canes, if that is possible, if that happen, then this is called the inverse of this function. Okay, so what is happening here? Now we have a different machine. We have a different machine where we actually inserted those sugars, huh? And as an output, if we are getting these sugar canes back, then we'll say that this machine is doing the inverse of, right? This is the inverse. This is just simply doing the inverse process of this machine. So this will be called the inverse function. Let me give an another example. So yeah, so in this case, this will call the inverse function, and we'll denote this by f inverse. Okay, it's a notation to denote. So if f is a function, so inverse function is denoted by f of f to the power -1. So we'll read this as f inverse. Okay, now the question is what, when this exists, because we know that if we have in such kind of machine that we are inserting sugar canes from this side and we are getting the sugars, so these kind of machines never exist, where we are inserting the sugars and we are getting the sugar canes. So these kind of machines are never exist. But let me give you another example. Let we have a machine which is called a refrigerator, okay, freeze. Okay, so let this is a machine. Okay, so here we consider water as my input. We are considering water as my input, and when we are inserting this water in my refrigerator, then we are getting some ice. Okay, some ice. All right. Now, again, I'm considering another machine and I name this as like microwave. Okay. So some heater you can consider. Okay. And let me consider this a microwave. And when I inserted this ice in that particular box, in that particular machine, what we are getting? We are getting the ice bake, sorry, water bake, right? So this is happening. But in that case, this was not that feasible. In case of sugar example, this was not that feasible, but in case of this water case, so this is feasible with some different machines. In that case, if we name this as F, then this is actually existing. This is actually, we have this kind of machine, and we can say this microwave as the inverse of this refrigerator. Or we can say like that. Is it? Now the question is why this is not happening in every cases. Okay, why in this case we are getting the same elements, the same element, that means the water bag. Huh? So here we are starting from the water, and when this is passing through two machines, one is F, the other one is inverse of F, we are getting the water bag. But here in this case, this is not that feasible. Why we are not getting the sugar cane bag? So there are some conditions. Okay, so mathematically also we can have different, I can give you different examples, but let's not go let's not discuss about some mathematical definitions, mathematical examples. Let's not consider. So let's go with these two example. Okay, then what we can say, my question is what, why this is actually happening, why we are not getting these kind of machines which actually produce the sugar canes, or why this kind of machines are we are getting this kind of machines. Now the answer is very simple. When we have this kind of functions, okay, when we have this kind of functions, and when this function satisfying two properties, one is one and another one is onto. Okay, that means if this function follows the bijective property, in one word, we can say if this function satisfies the bijective property, then actually what is happening? Then actually we can say that these kind of machines will exist. These kind of functions will exist. So this is the only condition to have the inverse of a function. Okay, the inverse of a function will exist only when the function is bijective. Okay, so this is very important. Okay, now you may think about some why you are not getting these kind of things in your high secondary, but you are actually getting those. Okay, in your in this definition was there in your high secondary second year course. Few more examples I can give. You already got this kind of function sin x. Okay, f of x equal to sin x, I may have a function like this. You know the inverse of this function, you know about sine inverse of x. Okay, this is an inverse of sine function, similarly cos inverse. So you are getting lots of functions, the inverse functions in your high secondary program. Okay, now see, one more thing I just want to mention here. If some function which is not one, then we can also refer this as many one. Okay, so if we use the term many one, it means this is not one. Okay, this means not one. All right, again, if some function is not onto, then we can refer this as into. We can refer this as into. So into means not onto. All right, so now, so I will conclude this whole function part here. So now I'll move to the next concept I needed for my content, which is limit. Okay, I'll move to this part, limit. Now before going to limit, so I want to ask you if you have any kind of query from this entire function part. Raise your hand if you have anyone have any query, any doubt in function part, you can raise your hand. Okay, Anurag.
Hello, sir.
Yes.
Sir, can you explain me many one and into function with respect to the conditions that you gave us yesterday? That
Yeah, we have.
uh,
I have.
uh,
See. This is an example of many one and into function both. This is many one because L is connected with more than one element. So this is not one. So this is a many one. And there is an element with no connection. That means this is into. All right.
yes, sir.
Okay. Any more question from anyone? If not, I can move to the next part. Limit. Okay. So yeah. So this is good that you are getting these things. So now limit. Okay. So generally people what? So if this kind of terms comes, okay, limit. So they simply try to avoid. Okay. So they try to avoid. People generally try to avoid the concept of limit, differentiation. Okay, this kind of concept. Okay, Tushar, do you have to say something? Do you want to say something? Okay.
So the picture is little blurry.
Okay. Actually, I'm also feeling that. That's why I was asking, is it clear to you all? So let's do this class like this. Huh? From the next class, I will change my camera. Okay. That's all right. So if you're not getting anything, wait for a few minutes. Huh? Now, is this clear?
Yes, sir.
Okay. All right.
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Now, let's discuss about limit. Acha, again, before going to the mathematical definition, I will not directly discuss what is the mathematical definition of limit, but let me give you an example. So I prefer to give you an example before going to the mathematical definition. I have a wall here. Okay, I have a wall here, and yeah, I have a wall like this. So this is the floor, and I have a wall here. Now I have two students. Okay, one student is this side of this wall, the another one is this side of this wall. Okay, I have two students behind the walls. So one is this side and the other one is this side. Okay, then I give a command to both of them. Okay, then I give a command to both of them. First, I told this one that go and approach to the wall. What is my command? Approach to this wall and touch this wall at some point. Okay, what I command him? I told him that approach to this wall and touch this wall at some point. Then what can he do? He can approach to this wall like this, okay, and let his touching at some point this. Okay, he's touching at some point like this. Okay, he's approaching to this wall and touching at this point of this wall. And the same command I have given to this particular student also. Okay, in that case, he also or he or she will also approach to this wall and touch the wall at some point. Is it all right? He or she will also approach to this wall and touch this wall at some point. Am I correct? So this is the situation, right? So in this case, these kind of things are nothing but the limiting case. Okay. Now this point where actually the student touched, okay, we'll call this as left hand limit. Okay. And this particular point where the other student touched, this will named as right hand limit. Okay, I think these two terms, left hand limit and right hand limit, this is not new to you. Okay, so are you familiar with this term? So I'm not asking about the
Yes, sir.
definition. I'm not asking about the definition.
Yes, sir.
You
Yes,
got this
sir.
Yes, sir.
terminology, right? Okay, all right.
Yes, sir.
So yes. See, why we call this as left hand limit? From my example, when I give the command to this particular student, he was approaching from which direction? So this is the wall and this is the left side of this wall, right? So he was approaching from the left hand side to touch this wall, and at this point he have touched. So this point will refer as left hand limit. All right. Now, similarly, this student was approaching from the right hand side. Okay, this is the right hand side of this wall, and he was approaching from the right hand side to touch this wall. So this point will refer as right hand limit. In some cases, now the condition is different. Okay, if in some cases, again let me draw this situation. So I have two students both side of the wall, and if in some cases, if both students touch at the same point, okay, when they are approaching to this wall, when I give the command like that, go and approach to the wall, go and touch this wall at some point, then if both the students touch at the same point, then what is actually happening? Then the left hand limit is becoming equal to the right hand limit, right? And in that case, actually, we can say that the limit exists. The limit will exist. Huh? And this particular point, instead of calling this as left hand limit or right hand limit, we'll simply call this as limit. We are not going to refer this as left hand limit or right hand limit. Okay. So these left hand, right hand, these are only because of the directions. Otherwise, these points are the limits, right? So, but this was the limit when we are approaching from the left hand side. This was the limit when the boy was approaching from the right hand side. But since here in this case, we are getting the same value, it's direction independent. From the right hand side or from the left hand side, we are getting the same value. So instead of calling this as left hand or right hand, we'll simply call this as limit. Are you getting this? Any doubt?
No doubt, sir.
Anyone have any doubt here in this particular description? So I will compare this with your definition of high secondary, the definition you are getting in your high secondary course. So do you have any kind of doubt here? No, sir? Okay.
No.
Okay. Now, since as I told you in the last class, Deepak Mete, can you unmute yourself? Unmute yourself. So, okay. So now let me name them. Okay. So everything have to give some name. So instead of wall, this may be something else. Okay. So it cannot be wall. It may not be wall. So let me give a name to this. Okay. Let me call this as F. Okay. And this particular line where the boys are standing, let me call this as X. Okay, sorry, let me call this as Y, let me call this as Y, and let me call this as X. So X may be anything, right? So this student may be here, maybe here, maybe here. So the position I can describe as X. So last class I told you that what is X, what is why, when we need to use the X. Like if I'm referring any student from my class, I will use X. Okay, so if I using the point as this, point as this, point as this, I'll refer all those points on this line as X. So X is a random element. Let this wall is standing at a point X equal to A. So this point is fixed. The wall is standing at a point X equal to A. Now this point is fixed. Now, the entire story I told you, that I give a command to the student and I told that approach to the wall and touch that wall at some point. That story. So I have some notations, right? Otherwise, so I can't write all those things in my maths book. Okay, so there must be some notations. So to describe that kind of situations, that kind of commands, let me use a symbol LIM. This is a symbol to describe all the commands I have given. That go to the wall, touch the wall, or that kind of commands, that kinds of command we we use. So let me use a symbol to denote those kind of commands, LIM, and we read this as limit. And what was my command? Command was, I told X to go A. Because the wall was standing at A, I told X to go to A. x tends to a. And what I told that touch this wall, okay, at some point. So this is nothing but work done, right? So I can also refer it as f of x. I can refer this as f of x, this kind of work. So I told him that, or I can also write y instead of f of x. That is not an issue. So y equal to f of x. Last class I described why I am writing y equal to f of x. So the name of this particular wall was y. So I told them go to this y at task. First go to x. Sorry, x go to a, then touch this wall at some point. Whole situation. Let me write with the help of this limit of f of x, x tends to a. Is it all right? Is it all right here?
Yes, sir.
Okay.
Yes,
So
sir.
this is nothing but limit. So it will call. So this symbol, this representation is called a limit. As I told you earlier, that if this point is called a limit actually. Now this one, when I was referring, I commanding that to this particular student, he was moving from this direction, left hand direction, right? Then how to describe this with the help of this symbol? I give the same command. I told him to approach to wall, approach to a, and touch this wall at some point, but he will approach from which direction? From the left hand direction. So to maintain, to denote the direction, let me give some notation. So a minus. This minus is simply to denote the direction, and this is referred as the left hand limit. Similarly, this particular point, which was known as right hand limit, so this was nothing but same command. Okay, go to A and touch this wall at some point. But in this case, the ball will approach from the right hand direction. So to denote the direction, let us define as A plus. Now mathematically, if these two happen, if limit of x tends to a minus f of x is equal to limit of x tends to a plus f of x, when this happens, then we can say that then limit of x tends to a, f of x exists. It will be there. Okay, this value will be there because both are same, and it is called limit of f of x when x tends to a. So we'll call this as x tends to a. Okay, x tends to a. So this is about the limit. So do you have any kind of doubt? Do you have any kind of doubt in this? This is the whole story of limit. There is nothing. Okay, let me give you a similar example. So this is Kaziranga University. This is Kaziranga University. Okay, so this side of the Kaziranga University, we have the Dergaon. Okay, we have Dergaon. And this side we have Jorhat. You have not come to Kaziranga University yet, so it will be new to you. But this side we have Dergaon and this side we have Jorhat. If two of my friend is coming to Kaziranga University to meet me, or meet at Kaziranga University, okay, two of the people are coming to Kaziranga University and they will meet each other. Okay, then what happened? If this particular person from Dergaon will come to the gate, the main gate of Kaziranga University, and if this person from Jorhat is actually came to the backside of Kaziranga University, can they meet? I think they can know, right? They can't meet each other. Okay, in that case, this particular point where this the main gate will be called the left hand limit, or in this case, the back side of this Kaziranga University will be called the right hand limit. Okay, and if both the people can meet, right, then they have to be at the same place at the same time, right? In that case, we can say that the limit exists. Okay, and that particular place where they actually meet, it will be called the limit of the entire situation. Okay, Darpon, do you want to say something?
Sir, can you explain the greatest integer function in relation to limit?
Yeah, I'm not going to describe those functions, but obviously I will discuss those. That's one more thing. Don't message me in the chat box, as I already told you.
So means
So why was the concept of limit invented? So yeah, we are going to discuss about these things. So basically, uh, almost all the practical things now we have in these days, those can be expressed in terms of a term called derivative. So we are going to discuss those, and to describe those things, these limiting concepts are very, very essential, very, very essential. Without knowing these concepts, so actually we can't describe anything. We can't describe anything. See, there is some difference between a Rajmistri and an engineer. Do you feel the difference? A Rajmistri can also build a house, right? And
yes,
what a civil engineer can do?
yes,
He can also build a house, a built-in bridge, right? Right? But what is the difference then? The difference
yes,
is the Rajmistri don't know mathematics and an engineer know mathematics. That is the only difference. The using mathematics, the engineering is nothing but the application of mathematics. Okay? So, and the thing, basic concepts derived from these concepts. These are the basics. These are the basics. Based on this, we are actually going to build the whole engineering syllabus. Okay, any question from anyone? So if not, I can move to the next part, continuity. So otherwise, I'll skip this limit here. Any kind of doubt if you have.
I didn't understand limit.
Which part?
The whole part limit.
From the starting.
Yes, sir. The only limit part.
So if this is happening, please go through my YouTube video, huh? Because I can't describe from the first initial concept. So please go through the YouTube video, and still if you have any kind of doubt, again I'll repeat that. It's all right.
Okay, sir.
Okay, I'll provide the video. So it's meaningless to describe it again from the starting. Any more specific doubt here? Any more questions? Okay. If not, so let me move to the next topic, which is continuity. Okay. So after discussing the concept of limit, we can move to continuity. So continuity, what is this? So have you ever used this term, except mathematics? In mathematics, you know this concept, continuity. But except mathematics, do you ever use this term continuity? Anyone? Anjali, do you ever yes?
no, sir.
Kutub, actually, I'm not getting your voice. It's broken, right?
No, sir.
No, you said no,
Network issue,
right?
sir.
Kutubuddin, actually,
Yes,
voice is not that
sir.
clear.
Yes.
Let me,
Sir, in fiction,
Network issue.
Darpan, what say?
sir, there are words like continuity, sir, which
No,
doesn't have an
actually,
end means.
don't go to any science subject. Don't go to any science subject. Apart from science, have you ever used the term continuity?
Sir, continuous we have heard, but continuity.
Exactly. The continuous you have heard, right? So I am doing this class continuously from last half an hour. That is nothing but the continuity. So that is the actually basic difference. So we are using the terms regularly, but we are not feeling that these are the terms we are also using in mathematics. We feel that mathematics is something different, but it's not like that. The continuity is simply like that. Okay. So there is some different mathematics a language. So there is a way to express these terms in mathematics, but the overall concept is simply same. Okay, so continuity means if I'm doing something continuously, then that is a continuity or continuous function. Okay, so continuous, in some other word, we can also say that continuity means with no break. If we have a function with no break, then we can say that it's a continuous function. I'm doing this class from last half an hour. So within this half an hour, this whole function is continuous. That's all. If I want to express this function in terms of graph, okay, so if I have a graph like this, okay, if I plot the whole thing in a graph, and within this portion, okay, within this portion, I don't know the remaining part, okay, I don't know the remaining part, but within this portion, since there is no any break, so I can say that this function is continuous within this particular area. If I name this function as f of x, as I told you, f is just the name. Okay, if I name this function as f of x, then I can say that, and if we name these locations as a and b, like this is Jorhat, this is Dergaon. These are some locations, but we can't write the names here. So in mathematics, instead of some big names, we used to write the small names. Okay, so if this is a, this is b, so within a and b, since there is no any break, so I can say that this function f of x is continuous within a and b. That's all. Okay, that's all. So that is the concept of continuity. Okay, now if I'm so this continuous function means what? So if a function is not continuous, then the function is called discontinuous. Like if we have an like this function like this, so if we have a and b here, so within this region, if we see there is a break, right? So this is not a continuous function. Or if we have a function which is not continuous, in that case it's also known as discontinuous function. Okay, now, so we have 7 minutes more. So please give your attendance first. Then I will continue with this continuity concept. Don't write doubly only. Department and your name. Okay, all right. So see, now mathematically, how can we describe this continuity, the concept of continuity? The thing is what? So there is a very easy definition of continuity in mathematics. Can anyone tell me that? What was the mathematical definition of continuity? Can anyone tell me that? Do you remember? See, there are 87, 86 participants. So I can expect that at least one of you know what was the definition of continuity you got in your high secondary course. Can anyone tell me? Yes, Kalpataru.
So if f of a equals to limit x tends to a f of x যদি
Yes,
আমি
if f of a
equal
equal
কৰিব
to
পাৰো
limit x tends to a f of
f
x.
x.
Okay, so yes, thank you. So this is the definition. Now, what does it mean? What does it mean? So this part is what? This part is limit. Just I have described, right? So limit or this particular value, limit is sometimes also called as limiting value. So limiting value means this value we are getting from the whole concept. This is the limiting value. And this f of a is what? If we have a function f of x, okay, then at x equal to a, at this point x equal to a, this, if we replace this x by a, So it will be called the functional value, right? So this is called a functional value. So f of a will be known as the functional value. So this is called a limiting value and this is called a functional value. So this definition is correct. If this happen, we actually says that the function f is continuous at this point a. But what does it mean? This means that the functional value, if the functional value is equal to the limiting value at some certain point x equal to a, then we can say that this function, given function f of x is continuous at that point. Okay, now here with the help of this graph, let me describe that. So at any point within this interval, we can actually say that this is continuous. Okay, that means first of all, the limit of this function, let me call this as capital A, capital B, and let we have a point A here. Okay, now what is f of a? F of a means this particular point. So if I draw a perpendicular line from this point to the graph, okay, then this point where this line cut, that is the f of a, the functional value. Okay, now this is the limiting value where we can actually describe the limiting value. Now instead of touching this line, okay, in the concept of limit, actually will approach, the x will approach from this side and x will approach from this side, and the student is now going to touch at this line. Okay, when the x was here, the functional value was here, limiting value was here. When we are approaching from this to a, the limiting value is also approaching to this side, and when they is approaching from this side, actually when x is approaching to a, we can say that f of x is approaching to this particular point, right? Since there is no any break. Similarly, if we are approaching from this side, if x is approaching from this side now in this case also, f will approach from this side, f of x will approach from this side, and when x is almost about a, so this f of x will become like f of a. Yes, so in that case, limit of this is also becoming this particular function. So what we can say, that limit is also existing here, and this value is not the limit, this value is nothing but the limiting value, and this was actually the functional value of this function. So at this point, this function is continuous. So that is the way how can we actually explain the continuity for this particular graph. And if this is happening for each and every point within this, okay, then we can say that within this particular interval, the function is continuous. But in reality, what is happening, the continuity means there is no any break. If we have this kind of functions with no break, we can say that yes, this function is continuous without verifying that. But remember one thing, to become a function continuous mathematically, these things should be happen. The functional value should be equal to the limiting value, and to existence of limiting value, the left hand limit should be equal to the right hand limit. Okay, so we are almost going to end our session. So if you have any kind of doubt, you can write those doubt in the as a comment in the YouTube session, YouTube videos. So thank you everyone.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.